Welcome to 16 weeks of SATs, week 10. Now, this week is one of the most important weeks, and it's a brilliant week because there's two videos that are going to be added to help you with your SATs. Now, this video, today's video that you're going to be watching, is all about adding and subtracting fractions with the same denominator. So this lesson is a very short lesson compared to some of the others, but it's all about the foundations of these types of fraction questions. And as we go through the next few weeks, there's probably 5, 6, 7 different subtle variations of fraction questions that we need to know how to attack each individual one. And we need to start here today by adding fractions with the same denominator, adding and subtracting fractions with the same denominator. Okay, so this video is going to explore the different parts of the fraction. It's important that we understand that, and also going to take you through a really simple approach to these questions on how to solve them and how to get the marks really quickly. So this video today is very straightforward. You'll get into the questions and they're very simple to answer. There's not actually that many of them in the SATs papers, but this is where we need to start before we move on to the next video. So we're going to get straight into it. So today's video is all about adding and subtracting fractions with the same denominator. If you're not sure what a denominator is, let's take a look and get straight into the teaching. So let's get started with this week's content. So to begin with, the first things that we need to look at is just this week's video should be relatively short, because this week is all about, or this video is all about just understanding the straightforward process of adding fractions with the same denominator. So the first step we really need to think about is, what is the denominator? So if we take a look at a fraction, I'm just going to highlight off certain parts. We've got the top number, we have a fraction bar across the middle, okay, separating this number and this number. So this number, the top number, is called the numerator, okay? So I'll just write that somewhere. Oh, we need the pencil. So we've got the numerator. And then below that, we have what we call the denominator. So we're going to highlight that in green. So this number is the denominator. So again, it's a bit awkward. Denominator. All right. So again, I'll just highlight those off in green. So when we're referencing the numerator and the denominator is the lower number in the fraction, and the numerator is the number at the top. Okay, so here we've got the yellow number and the green number. Now, essentially, if we think about fractions, when we go back to just thinking about what a fraction is, fractions, decimals, and percentages are generally referring to the concept of less than the whole. Okay, so if we think about number, as in the number 1, that is one whole. Okay, generally we need fractions and decimals to identify and represent amounts that are less than 1. Okay, so that's all really fractions are, because sometimes we can't just deal in 1 or 2 or 3. Sometimes we need the amounts that are in between 1, 2, and 3, if that makes sense. So the fractions that we see here, like a quarter and a half, that should be quite familiar, are just representing an amount that is less than a whole. Okay, and we can visualize that down here at the bottom. Now, fractions are always equally shared, so forgive my less than straight lines here. But when we talk about the numerator and the denominator is basically representing how many parts the whole is being split into when we're referring to it. So in essence, this whole that it's referring to, or the whole, is broken into 4 parts. So we can share this shape roughly into 4, imagining that these are completely equal. Now, my wiggly lines don't necessarily show that, but essentially we're thinking about the whole as broken into 4 parts. And that's what the denominator is representing. So we can shade that in a little bit. We'll do that with green. Sorry, we won't do that with green. So we've got that. And the numerator is representing how much of those 4 parts that we're actually working with, that is represented. So you can see here in 1/4, essentially, if we go with the yellow color, that is what 1/4 represents, one of the 4 parts of the whole, okay, equally shared. And this one, this number, There's two of those, two of the four, which we also know is half. Okay, and you can see that visually with these circles, that we have one of the four and two of the four parts of the whole there to add. Okay, now obviously this is an addition problem, so we've got 1/4 add 2/4, very, very simply equals 3/4. Right, and that shouldn't really come as too much of a surprise. So again, we'll just represent that here. So we've got 1, 2, 3. Now, ultimately, when it comes to arithmetic, what we tend to find is we just want to get the answer, okay? And these lessons aren't really about diving too much into the complexities of fractions and decimals and everything that comes with that. But I just wanted to represent that in the first question, is that we really need to understand the denominator and the numerator, okay? Now, the key thing when it comes to the arithmetic paper, for me, it's all about clues. I'm going to write that word in red because it's really important. What are the clues that are available to help us just get into answering the question? And the big thing when any fraction question comes up is my first prompt is, what's the problem? Is there a problem? Now, the key is, can we spot that we're always looking for denominators that are the same? Now, if the denominators are the same, it basically gives us a bit of a green light to just go ahead and solve the problem. All right, so I'm always looking, are the denominators the same? In the next video, we're going to look at if the denominators are different. But if they're the same, we can just go ahead and add and subtract. So that's the key thing. So if we look at this question, forget everything down below that I visualized. If we have 1/4, or 1/4, add 2/4. If I can spot that the denominators here are the same, we just go ahead and add the numerators and the denominator remains the same. So that would just go and be 3/4. Super, super simple. All right. So the key thing we're always looking for with fractions in the arithmetic paper is, are the denominators the same? If they're the same, we just go ahead and add and subtract. Let's take a look at another couple of quick examples. So again, if we were to look at this problem and I was coming in from the next question and we looked at it, obviously we're not going to highlight things, but the first thing I would be looking for is the denominators. I see it's a fraction question, just in general. I spot it's a fraction question. Then my first thought is, are the denominators the same? They are, so we're just going to add. All right, very, very simple straight away. So we're just going to add the numerators. I'm just going to highlight them in yellow just because we've been doing that just for consistency. Go back to my pen. And that's basically 2 add 4. 2 add 4 is 6/3. The denominator remains the same. All right. So our answer would be 6/3. Now, at this point, we also need to have an awareness of our ability to exchange improper fractions to mixed numbers. Okay, so this fraction here, if I gave us just another simple example, let's have a look down here, and we said, right, we've got, let's say 2/7 add 3/7. Now, my first instinct is, are the denominators the same? Yes, they are. So we just go ahead and add, and that's very, very simple. 2/7 add 3/7 is 5/7. Very, very simple. Are the denominators the same? Yes. Then we just go ahead and essentially give ourselves the green light to just go ahead and answer the question. Okay, there's nothing more complex about it. And what we have here is a fraction that is a proper fraction where the numerator, this number, is smaller than this number. So we have a proper fraction. This number is an improper fraction. And that's the reason, is because the numerator is larger than the denominator. Okay, so sometimes we need to convert to a mixed number. And all we do to do that is we divide this number into this number. We divide the denominator into the numerator, and we go, how many 3s are in 6? Well, you probably sat there thinking, well, that's really obvious. And it is obvious. Okay, 3 into 6 is 2. And that's it. It's 2 wholes. All right. So I'm just getting a pen up to write that in. Here we go. So that would just convert into 2 as a whole number. All right. Very, very simple. Because essentially, if we look at 6/3 represented in wholes, 1, 2, 3, 4, 5, 6, and we think of these as thirds, how many lots of 3? Well, we've got 1 lot of 3, 2 lot of 3. Now, essentially, they are wholes because 6/3 is 3/3, which is this fraction here. add 3 over 3, which is 6 over 3, which is also 2, because there's 2 lots of 3 and 6. So it all sort of links together, but essentially we need to get into the habit of converting improper fractions into mixed numbers, or at least I think just for our own confidence with numbers, we should be able to interchange between these two anyway. Okay, 6 over 3 in the SATs, I'm pretty sure it gets you the mark anyway. If you just put that in the blue box, 6 over 3, even as an improper fraction, you would get the mark, but you would also get the mark if you wrote 2 as a whole, okay, because essentially they are the same thing. But yeah, but the main message here is if we see the denominators are the same, we just go ahead and add and subtract. Let's take a quick look at some subtractions. So again here, if we just highlight the parts of the fraction, so we have our denominators and we have our numerators. Very, very simple. Now again, the key thing is, I would be saying here, is if we went to answer the question, or I saw this question as a SATs, I spot that the denominators are the same. So essentially that's a green light to just go ahead and do the question. You can, in your head, you can just think, right, denominators are the same, I can just do the question, okay? There isn't another little strategy that I need to do. So essentially this is just 5 take away 3. Very, very simple. You would just write 2 over 6. And if there was a blue box at the bottom, like on a SATs paper, you would have to make sure that you wrote that in there. But essentially that's all we're looking to do. And the conversion of the mixed numbers that we looked at in addition in the previous slide, you won't get this with subtraction problems when it comes to fractions, because the larger fraction, or the larger of the two fractions, has to come first in the problem, okay? So we've got a larger fraction, take away a smaller fraction, gives us another smaller fraction. And obviously these two fractions, if we added them, would equal this, okay? So essentially those problems are the same. Now if I just do another one just for the sake of it, and we said, right, what is 11 over 12 take away 6 over 12? Again, if we saw that question, I would be hoping you'd go, well, Andrew, the denominators are the same, so that is a green light to just go ahead and answer the question. And it is. So 11 take away 6 is 5, so it would just be 5 over 12, and that would get you a mark. So the beauty of these is that we can just, as we see them, denominators are the same, do the problem and get the mark. They are very, very simple. And again, if we just have a look at one last one, this video is super short because it's so simple. Again, I'm just going to highlight them off. So we have the denominator, and again, it's coincidental that we've got this in green because we really want that green light effect. So the numerators are there straightforward. The denominators are the same. Both of them are 13. So essentially, we're just going to subtract. 9 take away 7 is 2. So we're left with 2 over 13. Very, very simple. Okay. And we do that in the SATs, we will get the mark. Now, the key thing with the SATs, if we just have a look at this next question. So again with the SATs questions, we'll rub that out. All we need to think about really is, and in fact, this is a good little tip. And again, it's just about what to expect. Now, obviously, with this one, you'll probably look at this and see the answer already. So the top tip is obviously we don't need to. With any question in the SATs papers, we don't need to write out a straight. If you just know the answer, great. Let's just go ahead and write that in. So here we would be saying, well, that's 5 over 11, and it is 5 over 11. So you would get the mark. But it's just important as this to reference is that, again, all we've done there is we've got 9 over 11, take away 4 over 11. We've seen that the denominators are the same. So that gives us the green light to go ahead and do the calculation, which is basically just 9 take away 4. We know that. So we've got 5 over 11. Now, just as a finisher, having scanned through all of the SATs papers to find example questions, this was the only one that I could find that had an addition or a subtraction with the same denominators. And the only reason I can think with that, and again, look at this question. This is the second question in a paper. So literally the second question that you're getting is a fractions question, which is quite strange. And the reason being is because it's just that straightforward. Okay, there isn't really any maths to do. The only way you're going to get it wrong is if you get thrown in all of a sudden panic, okay? Because really, just remember denominator is the same, it's just green light. Go ahead, answer the question, just add or subtract the numerators. Okay, dead simple, job done. Make sure that answer goes in there. So as soon as you see these, denominator is the same, just get that answer written in, and it should take 5 seconds. You've got the mark, you're on to the next question. And this week I've just jotted some questions down because they're relatively simple. Again, we've got some addition, dead straightforward. So we've got 2 over 6, add 3 over 6, and so on. So again, pause the screen, have a go at these. And again, you can make them up yourself if you want to as well. But again, as long as if you go through these and you're confident, you should get every one of them right, very straightforward. You could probably even do them mentally. So here you're looking at 2 over 6, add 3 over 6, it's 5 over 6, isn't it? So we can see them. So even mentally going through it is important. And again, I've just got some practice in over here for converting improper fractions to mixed numbers. So again, if we were going to do the first one, remember the strategy is just basically dividing the bottom number into the top. Okay, so how many 5s in this first one? How many 5s would we get in 6? Well, we would get 1 whole, wouldn't we? And there would be 1/5 remaining, because we're dealing with fifths. And just to visualize that, if we've got 6 fifths, so we'll have 6 of them, 1, 2, 3, 4, 5, 6, and we're dividing 5 into it, then we're basically looking for a group of 5. So that is that there. So that's 1, which is basically this. We've got 1 whole now, because that is representative of 5 over 5. And then we have 1/5 remaining. So essentially we have 1 and 1/5. So it's very, very simple. The second one, again, how many 2s do you get in 4? Well, it's 2, isn't it? Okay, so very simple. So again, that comes with practice. So I always recommend, I would do a full lesson on this at least, just so that we get that confidence of dividing into, okay? And sometimes it can help to visualize it like this. Essentially just draw out the top number in terms of 1s, 1, 2, 3, 4, 5, 6. How many groups of 5 do you get? And then whatever the remainder is the fraction as well. So we've got 1 whole, 1 and 1/5. Okay, dead simple. So that's this week done. A much shorter video, and I would definitely recommend, if you've just finished this video, to move on to the next one, which is going to be adding and subtracting fractions with different denominators. So what are the steps that we need to take to solve those? Because those questions are very, very common in the SATs. You will definitely get 3 or 4 of them in your SATs every year. So the next video is very, very important. But don't forget, denominator is the same. Green light for go. Off we go. Get the marks. Very, very simple. So that is adding fractions and subtracting fractions with the same denominator. Very, very simple, very straightforward. We've got that green light. So if we can spot those questions when they come up in the arithmetic paper, we can answer those questions very, very quickly, very straightforward, and get the mark. And the likelihood is that they're probably not going to crop up in that great of an amount. There may be 1, there may be none. There probably won't be 2. So all of this content that we've covered in this session is, again, covered in even more detail in Sats Like a Ninja. So get a copy of this if you can. The link is in the video description below. And that sort of brings us to the end of this video. The next video is all about adding and subtracting fractions with different denominators. So that is the next step. Make sure that you go and watch that video. That should be linked somewhere around here. Please make sure you subscribe to the channel. It's really, really important, and it helps me enables me to make more and more videos. Okay, so that support is really, really important. So check out the next video. Make sure you subscribe, and like I said, if you can, get your hands on a copy of Sats Like a Ninja. It's the ultimate guide to Sats. So thanks very much for watching this video. Go and watch the next video, adding and subtracting fractions with different denominators, and go and smash your Sats when they arrive.